YouTube channel. My name is Salami Titidokwadini, and the topic before us is the continuation of differential calculus. And we'll be looking at what we term as a reciprocal function. And when we are talking of the reciprocal function, what is the meaning of reciprocal function? Reciprocal function is when we have 1 over what a function of f of x. Now, how can we solve this? When we are having 1 over a function of x, that means we are having the reciprocal function, which says it is the meaning of what minus the differential of the denominator over the square of the denominator. Wow. For instance, how can we differentiate y is equal to 1 over x? The differential of this will give us dy dx is equal to minus the differential of the denominator 1 over the square of the denominator. That means when we are going to differentiate 1 over x, the differential of 1 over x will give us minus 1 over what? Over x squared. For instance, let's look at this. Differentiate 1 over what? Sin x. How can we differentiate 1 over sin x? This will give us what? Y dy over what? Dx is equal to, make use of the reciprocal function, minus the differential of the denominator. If you differentiate sin x, what do we have? Cos x over what? Over the square of the denominator. And don't forget, what is sin x over cos x? Sorry, cos x over sin x. Cos x over sin x will give us what? Cot x. And what is the inverse of sine? The inverse of sine will give us what? Cosec x. And if you don't want to make use of a reciprocal function, you can also solve it like this by saying, what is 1 over sin x? 1 over sin x is what? Cosec x. And don't forget, what is the differential of cosec x? The differential of cosec x is what? Minus cosec x cot x. And now, let me tell you, what is the differential of cot x? The differential of cot x will give us what? Minus cosec squared x. Now, for instance again, let's look at this. We have y is equal to 1 over x squared. They are asking us to find the value of what? Second derivative. Wow. How can we solve this? That means to get your first derivative, your dy dx, use a reciprocal function that will give us what? Minus the differential of the denominator, 2x, over the square of the denominator. And if you simplify this, that will give us what? Minus 2 over what? Over x cubed. And this is your y prime. And that means, how can you get your y prime? To get our y prime, we have it as what? Minus 2 is a constant, it will come out. That means if minus 3 is coming out, what do we have? We are left with 1 over s cubed. And if you try to differentiate 1 over s cubed, what do we have? Making use of the reciprocal function, that will give us minus the differential of the denominator, 3x squared, over the square of the denominator. That will give us x's. And that means your y prime will give us minus 2 times minus 3 will give us what? 6. X squared over x6 will give us what? X4. So it's very simple. Now, so let's look at this again. We have y is equal to 1 over 1 plus x a power of half. Wow. So how can we solve this? That means we are also going to make use of what? Of a reciprocal function. And how do you make use of the reciprocal function? It will give us minus the differential of the denominator. And this one is a function of a function. That means solving this, our aim is for the differential of the bracket times n, which is the power, times x, which is the bracket itself, n minus 1. That will give us minus half over the square of the denominator. And if you square this, what do we have? We have it as what? A power of half times 2 will give us what? 1. Do you get that? Again, minus the differential of the denominator over the square of the denominator. And this time, this will give us what? Minus 1 over 2 times. Now, don't forget, this will give us minus half minus 1. Or better still, that minus will come down. That will give us what? 1 over what? Over 1 plus x. We have it as what? Half plus 1. Do we get that? Half is coming to meet 1. And this will give us what? Minus 1 over 2 into what? Into 1 plus x, a power of what? 3 over 2. And you can see that a reciprocal function is simple. So when we are talking of a reciprocal function, they can ask you a series, diverse kinds of questions under it. Now let's look at this. We have y is equals to 1 over what? Exponential 2x plus what? Plus sine 2x. Wow, it's very simple. And that is how can you differentiate making use of a reciprocal function. We have it as what? Dy over dx is equals to what? Minus the differential of what? Of the denominator. So if you differentiate this, what do we have? 2 exponential 2x. Differentiate this, what do we have? Plus 2 cos 2x over what? Over the square of the denominator. And that is all about what? A reciprocal function. So let's leave that alone and let's move to the next phase we want to look at. And the next phase we want to look at is what? Is a logarithm function. So let's quickly look at a logarithm function. And what is the meaning of logarithm function? Logarithm function is something like this: y is equals to the next. And when you have y is equals to the next, we have it as what? Dy dx is equals to what? 1 over x. But apart from climbing or knowing that ln x, the differential of ln x is 1 over x, please take note of this principle. What is the principle of ln? Ln will drag anything in front to the denominator. And when that man now gets here, you differentiate and write your answer as the numerator. Do we get that? So for instance now, let's look at this. Y is equals to the ln of exponential, let's say 2x, for instance. Now, how can you differentiate it? This will give us what? Dy dx. Ln will drag anything in front to the denominator. And when that man now gets here, it differentiates itself and you write your answer as the numerator. So solving this, what is your answer? Your answer is what? Is 2. For instance, again, let's look at this. We have y is equals to the ln of x squared plus 1. So how can you differentiate this? We have it as well. Dy dx is equals to ln we drag anything in front to the denominator. And when that man now gets there, it differentiates itself and you write the answer as the numerator. For instance, again, we have it as what? Y is equals to what? Sine 2x. How can you differentiate this? That means your dy dx will give us, then we drag it down, we have it as well sine 2x. And when that man now gets there, it differentiates itself. So if you differentiate this, what do we have? We have it as well 2 cos 2x. And what is your answer? We have it as 2. What is cos over sine? Cos over sine will give us what? Cos 2x. And as you can see, that it is very simple. Just know that ln will drag anything in front to the denominator, and when that man now gets there, it differentiates itself. Now, for instance, let's look at this. They are asking us to differentiate the ln of the square root of what? Of x plus 1. So how can you solve this? That will give us y is equals to the ln of what? X plus 1, a power of half. And if you are solving this, that means what is your dy dx? Your dy dx, the ln will drag anything in front to the denominator. And when that man now gets there, it differentiates itself. So if you differentiate this, that will give us what? Reciprocal function. That will give us what? Differentiate this. It is not a reciprocal function. Function of the function. A means the differential of the bracket times n, which is the power, times x, which is the bracket itself. N minus 1 will give us minus half. And if you solve this, this will give us 1 over 2 minus half will give us minus 1. And when that man now gets there, we have it as what? X plus 1. And as you can see, that it is very simple. Now let's take it down to, okay, we have looked at trigonometry. Let's take it down to, let's say, exponential and trigonometry being mixed together. We have the ln of exponential 2x plus sine x plus, let's say, 6x raised to the power 3. So how can you differentiate this? That means your dy dx will give us ln we drag anything in front to the denominator. And when that man now gets there, it differentiates itself. So when you differentiate this, what do we have? 2 exponential what? 2x plus differentiate this, what do we have? Cos x plus differentiate this, what do we have? 18x squared. So it's very simple. Questions can just be springing up and springing up. It's simple. So when we are talking of this, we have the lane of what x raised to power 3 plus, let's say, 4x squared plus 6. How can you differentiate it? The same thing. Your dy dx will give us lane we drag anything in front to the denominator. And when that man now gets there, it differentiates itself. So if you differentiate this, what do we have? 18x plus what? Plus 8x. So you can see that logarithm is very, very simple. But before we call logarithm an end, we have to know that there are three types of logarithm. Now, there are three types of logarithm. What are the types of logarithm? We have y is equals to ln x. We have y is equals to what? Log x base e. And we have y is equals to what? Log x base a. Wow. So when we are talking of y is equals to ln x, how do we solve it? You solve it normally. You just differentiate ln, we drag it down, and then that means you differentiate your denominator. You write your answer in the numerator. The same thing here, we have it as well. Dy dx will give us what? 1 over x. But when we are having log x base e, sorry, base a, that means how do we solve this? Your dy dx will give us, you differentiate normally, and after differentiating normally, you will now add log e base a to your final answer. So it's very simple. Again, ln x will give us 1 over x, log x base e will give us 1 over x, log x base a will give us what? 1 over x, log e base a. Now, without wasting time, let's solve few questions under this, and then we move on to the next function we want to look at. For instance, we have y is equals to the ln of sine 3x, or let's say tan 3x. Now, let's say the ln of cos 3x. How can you solve this? That means your dy dx will give us ln we drag anything in front to the denominator. And when this man now gets there, it differentiates itself. So if you differentiate, what do we have? Minus 3 sine what? Sine 3x. And what do we have? Minus 3 tan what? Tan 3x. And also, let's look at this. We have it as what? Log e. And we have it as 3x squared plus 6x plus 1. So how can you differentiate this? That will give us what? Dy dx will give us log base e. Let's differentiate normally. Ln will drag anything in front to the denominator. And when that man now gets there, it differentiates itself. And we have it as this. And let's look at this. We have it as y is equal to what? Log a, the square root of x cubed. Wow. So if we are having this, what do we have? We have it as what? Y is equal to, it must have a perfect power. And making it to have the perfect power is the power of what? Of 3 over 2. And what is the meaning? That means your dy dx will give us logarithm will drag anything in front to the denominator. And when that man now gets there, it differentiates itself. So if you differentiate this, what do we have? We have it as 3 over 2x. Now this will give us 1.5 minus 1. That will give us what? 1.5 minus 1 will give us 0.5, and that will give us half. Do we get that? And so if we solve this, this will give us what? 3 over 2. Now, we can mix this together by making use of what? Of indices. And what is the meaning of indices? That will give us 1 over 2 minus what? 3 over 2. And what is 1 over 2 minus 3 over 2? This will give us minus 2 over 2 will give us what? Minus 1. And if you solve this normally, we have it as what? 3 over what? Over 2x. And as you can see, that is very simple. But don't forget, that is not all. This is the final answer for our differentiation. But because it is log a, what do? We add log e base a to our final answer. Now we have looked at reciprocal function, and we have looked at what? At a logarithm function. So without wasting time, before we look at implicit function, let us just look at a question pertaining to what? Mixing a logarithm function with what? With a product rule. For instance, we have y is equals to x squared ln x. They are asking us to differentiate it. It's simple. So how do we differentiate? Your dy dx will give us u. A product rule formula says u dv dx. So if you differentiate ln x, what do we have? 1 over x plus what? V, which is ln x times what? Du. So what do we have? Du will give us what? 2x. So if you solve this will cancel this. What do we have? X. And if you multiply this will give us what? 2x ln x. And as you can still simplify. X is common. So if x is common, what do we have? 1 plus what? 2 ln x. And as you can see, that is very simple. Now, without wasting time, let us look at the meaning of what? Of the implicit function. Wow. What is the meaning of implicit function? Implicit function is telling us the basis of dy dx. And what is the basis of dy dx? Let us look at it like this. If you differentiate x, what is the answer? We have it as 1. If you differentiate 2x, what is the answer? We have it as 2. Now, if you differentiate x cubed, what is the answer? We have it as what? 3x squared. Wow, we know this before. But now, under the implicit function, your x can stand alone, your y can stand alone, your x and your y cannot stand alone. Now, let us look at the differential of y. Now, if you want to differentiate y, you differentiate y the way you are differentiating your x. And at the end of the day, you add dy dx to it. So far, it is y. So, differentiate y, we have it as 1. But because it is y, we are going to add dy dx to it. The same thing, what is the differential of 2y squared? You differentiate this normally, and what do we have? 4y. But because it is y, what do? You add dy dx to it. It's simple. And also, even we have it as something like this, differentiate, let's say 4y cubed. What is the answer? That will give us what? 12y squared. But because it is y, what do? You add dy dx to your final answer. So that is that about what? The implicit function. But when we are talking of implicit function, we can also have the mixture of x and y. For instance, they are asking us to differentiate with xy. So what is the differential of xy? It's simple. We make it of a product true formula. But now, looking at this, let me try to explain this. The same thing will be hybridized. I'm bringing chemistry into mathematics. Hybridization in the sense that the same element will add to itself. So if it hybridized, that means we are going to differentiate x here, we are going to differentiate y here. So if you differentiate x here, what do we have? 1. So multiply it with y, what do we have? Y. Differentiate y here, what do we have? 1 dy dx. Multiply your 1 dy dx by x, what do we have? X dy dx. It's simple. It's just that you differentiate your x, you multiply it by this, you differentiate your y, you multiply it by this. And for instance, again, let's look at something complicated like this. Wow. They are asking us to differentiate this. How can you differentiate? Differentiate your x with the constant. That will give us what? 6x. And then you multiply it with the function of your y. Plus, differentiate your y with your constant. What do we have? We have it as what? 12y cubed. Then dy dx. And then you multiply it with your x. It's very simple. And that is that about what? The implicit function. Now, let's now be looking at questions pertaining to implicit function. For instance, we have if x cubed plus y cubed is equals to 4. They are asking us to get the value of what? Dy dx. Wow. So for instance, how can we solve this? You differentiate this, we have it as what? 3x squared. You differentiate this, we have it as what? 3y squared dy dx. You differentiate it, what do we have it as? 0. And that means we are now going to make our dy dx the subject of the formula. And that means 3 we cancel 3. But don't say square, we cancel square. That means what is now your dy dx? Your dy dx will give us what? Minus x squared over what? Over y squared. So now, for instance, again, let's look at this. We have x squared y plus, let's say, 6x plus, let's say, 4y is equals to 0. They are asking us to get the value of dy dx. Don't forget, this is a mixture of x and y. And if you differentiate your x, what do we have? 2xy. If you differentiate your y, what do we have? X squared dy dx. If you differentiate this, what do we have? 6. Differentiate this, what do we have? 4 dy dx is equals to 0. And what do? We have to make what? Our dy dx the subject of the formula. So that means this man and this man is having dy dx. they will stay. And that will give us dy dx into what? Into x squared plus 4 is equals to this, and this is not having dy dx, they come out. And that will give us what? 2xy plus 6. And now, finally now, what is your dy dx? Your dy dx will give us what? Minus 2xy plus 6 over what? Over x squared plus 4. It's simple. Now let's now look at this question just to summarize everything on the implicit function. And then we now move on to the next function we have. For instance, now what do we have? We have it as what? Let's say y raised to power 3 plus x squared y plus 4x squared plus, let's say, 6x is equals to 0, and they are asking us to get the value of what? Dy dx at the point 1, 2. Wow, don't forget that what is a point? A point is a mixture of what? Of x and y. So for instance, differentiate y cubed. What do we have? 3y squared what? Dy dx. And this is a mixture of x and y. Differentiate your x. What do we have? 2xy. Differentiate your y. What do we have? X squared dy dx. Differentiate your 4x squared. What do we have? 8x. Differentiate your 6. What do we have? We have it as 6 is equals to 0. And that means this man and this man is having our dy dx, and we have it as what? 3y squared plus what? X squared. And this, and this are now having dy dx. That means they are going to come out. What do we have? Minus into what? 2xy plus 8x plus 6. And that means what is your dy dx? Your dy dx will give us minus into what? 2xy plus 8x plus 6 over what? Over 3y squared plus x squared. And don't forget, this is your dy dx, but they said at the point of what? Of 1, 2. That means at the point when your x is 1 and when your y is 2. So substitute it there. What do we have? Minus into what? Into 2. What x and y will give us 2. That will give us 2 times 2 plus 8 times 1 will give us what? 8 plus 6 over, what do we have? Y squared. 2 squared will give us 4. 4 times 3 will give us what? 12. Plus 1 squared will give us what? 1. And if you still solve this further, what do we have? We have it as minus, this is 4. That means 4 plus 6 will give us 10. 10 plus 8 will give us what? 18 over what? Over 13. And don't forget, this will give us what? Minus 1 whole number 5 over 13. And it's simple. And that is that about what? The implicit. Now, taking it down to parametric function. How do we differentiate a parametric equation? For instance, what is the meaning of parametric equation? Parametric got its origin from what? From variation. Now, for instance, we have y is directly proportional to t, and we have t is directly proportional to x. So how does y varies with x? That means if you want to find out y varies with x, everything in t belongs to x squared. That means your t is automatically what? X squared. That means your your y varies directly as well as x squared. And the same thing happens to what? A parametric equation by having y is equals to what? A function of t, and we have t is a function of x. So how can we find dy dx? So if you differentiate this, what do we have? We have it as what? Dy dt. Differentiate this, what do we have? Dt dx. And that means how can you get your dy dx? You multiply them together to have what? Dy dt times what? Dt over what? Dx. That means dt can cancel what? Dt. For instance, again, let's look at this. We have y is a function of t, and we have x is a function of t. How can you get our dy dx? If you differentiate this, we have it as what? Y over what? Dt is equal to what? 1 over t. And if you differentiate it, what do we have? Dx. Sorry, this will give us y dt. And if you differentiate this, what do we have? Dx over what? Over dt. And how can you get your dy dx? These them together. If you multiply, it will not give us dy dx. That means to have a dy dx, we have to divide them. Do we get that? Now let's look at some questions under what? Under the parametric equation. Now under the parametric equation, we have something like this. We have y is equals to 2t, and let's say we have t is equals to 1 over t, sorry, 1 over, let's say, x squared. And they are asking us to get the value of dy dx. So that means we are going to differentiate this. We have it as well, dy dt is equals to 2. If you differentiate this, what do we have? dt over dx. We don't have to stress ourselves here because it is a reciprocal function, and that will give us what? Minus 2x over the square of the denominator, and that will give us what? Minus what? Minus 2 over what? Over x cubed. And how can you mix this together to give us dy dx? That means your dy dx will give us what? Dy over dt times what? Dt over what? Over dx. So if you multiply them together, what do we have? Minus 4 over what? Over x raised to the power 3. Now, can they ask us a parametric equation involving a trigonometry? Yes. And how can they ask us question under that? Let's look at this. We have it as y is equals to sine theta, and we have it as what? X is equals to cos theta. They are asking us to get the value of what? Dy dx. That means you differentiate this, we have it as what? Dy d theta is equals to the differential of this will give us cos theta. And if you differentiate this, what do we have? Dy d theta will give us what? Minus sine theta. And what is your dy dx? You can now see that if you multiply, it will not go down, we are going to divide. And if you divide it, that will give us what? Cos theta over what? Minus sine theta. And what is your cos over sine? Your cos over sine will give us cos theta. So it's simple. Very, very simple. Now let's look at this last question under that. We have y is equals to, let's assume we have it as 2t for instance, and let's assume we have it as t is equals to, let's assume we have it as exponential sine x. And they are asking us to get the value of dy dx. So that means if you differentiate this, what do we have? Dy dt will give us 2. Differentiate this, what do we have? Dt over dx. Now I've taught you exponential function. Differentiate the power, that will give us cos x, and then you multiply it with the pressure. And how can you mix them together to have dy dx? So mixing them together, what do we have? Dy dt times what? Dt over dx. You cannot divide, you can only multiply. So if you multiply, what do we have? We have it as 2 cos x exponential what? Sine x.
Impact simplified.